Okay, I'm not really sure why my video died there, but at any rate, as I was saying, in the x direction, your v0x is just v0 cosine 60, and there's no acceleration, so I can just calculate immediately what this is using 22.9 as my v0, excuse me, and my x component then is 11.45 meters per second. In the y direction, I have to be mindful of the fact that there's an acceleration, so sine 60 degrees minus, I use a minus because acceleration is negative 9.8, so minus 9.8 times time. Now, I didn't actually calculate the time before, but if I go back here, I see that time, using this expression right here, time is 100 divided by v0 cosine 60. So let's calculate the time based on that. Whoops. 100 divided by v0, 22.9 times cosine of 60, and I forgot a parentheses. Okay, the time is 8.73 seconds according to that. I'll just write it as time right now, and then note that time equals 8.73 seconds. So then I can calculate this to be 22.9 sine 60 minus 9.8 times the answer I just got, so negative 65.75. Okay, now notice it's a good, 7.6 if I round correctly. Notice it's a negative answer, which is good, because if this at the end, you know, after the projectile has gone up and come back down, its velocity should be downward, which is the negative y direction. So everything is making sense there. I saw some people who sort of switched this to a plus because they didn't really understand why that minus sign was there. But, you know, if you think about it carefully, this is all very, very logical. All right, so what does the picture look like then? At the end, I have a downward velocity like this, and I can break it into components, which I've just found. I know that this component, in terms of its magnitude, is 65.75, and this component is 11.45, and therefore, using the Pythagorean theorem, the v final squared, let me just say the v final is equal to the square root of 65.75 squared plus 11.45 squared, which is equal to, put this down here, 65.75 squared plus 11.45 squared. Take the square root, I get 66.75 meters per second. Okay, very good. That's the final speed, total magnitude of that final speed. And now I also want to find the direction, so let me actually find, rather than that angle, let me find the angle that it is below the horizontal. So this angle here, theta. You can define the other theta and solve for that, but you have to tell the reader what theta you're solving for. The question just says find the direction. So you need to find a system to define a direction that's meaningful, that attaches for any vector, specifies in a clear way what the direction is. In this case, I'm going to define this angle to be theta and then tell you what theta is. All right? Well, that's easy enough to do. If I draw another triangle over here, I can see that for instance, let me do the tangent. the tangent of theta is the 65.75 divided by the 11.45. So theta is the inverse tangent, then, of 65.75 over 11.45, which is equal to whoopsie, 11.45. And I get 80 degrees, roughly, 80.1 degrees below the horizontal. Okay? All right. Hope that was clear. We'll see you for group problem number 6. All right.